All right, so now we're going to move into, again, still talking about scale drawings now and how they're going to be proportional. And we're going to dive more into that proportional part. Not just going to be about if it's bigger or smaller right now. So let's look at this example. It says Celeste drew the outline of a building for a diagram she was making and then drew a second one mimicking her original drawing. State the coordinates of the vertices and fill in the table. So we're going to say this one right here is our original. And this one right here is the second one. Try to spell second right. Okay, so stay in the coordinates. Now this is going to be important, guys. In your homework, you're going to have to actually draw these rectangles that we see right here. So this point right here, remember we have our x value and our y value. We're going over 5, 6, 7, so left and right movement first. And then we're going up to 15, 16, 17, 18. No, we're not. Let me start again. We're going over 7, we're not moving at all. So that's 0. But this point up here, we're going over 7 and then up to 18. This one over here, actually we'll come back down here. This point right here, notice we're going over to 10 to the right, 11, 12, 13. But we haven't gone up or down at all. So that's 0. And then we're at 13 and we're going up to 18 again. Our second drawing here, notice that we're at 7. But we haven't moved up at all or down, so that's 0. And then we go from 7 up to 5, 6, 7, 8, 9. So this becomes a point 7, 9. And over here we have 10, 0 and 10, 9. Okay, so that's identifying the coordinates. Again, left to right movement first, up and down movement second. Remember that for when you're plotting your points in today's homework. So now we're going to fill in the table. We have our original drawing and our second drawing. Our kind of like we've been doing with the x's and y's, except this time they're going to be in rows. The first row is x, the second row is y, dependent. The second drawing is dependent on the original drawing. So if we look at the height of the original drawing, that's up and down. Notice for these two sides here are the height. So how tall is this figure? Well, we're going up from 0 to 18 on both of them. So we're going to say its height is 18. And I'm going to try to draw with the actual drawing tool. All right, and its length on the original drawing here, its length, that's the distance from here to here. Now this is where it can get a little confusing because we actually have to count. We're going over 1, 2, 3, 4, 5, 6. Or you can look at it as we're going from 7 to 13. That's still going over 6. Now, the second drawing is its height right here, going from 0 to 9. So its height is 9, and its length right here is 1, 2, 3. All right, so again, if we wanted to find out its constant, and it's not going away, we're just going to be calling it a scale factor as we'll learn later. Remember, to find the constant, we always go y divided by x. So here we have y divided by x. So I could say 9 divided by 18, y divided by x. And I could reduce that. 9 goes into itself 1 time, 9 goes into 18 2 times. So we're saying the height got smaller by half. Okay? Anytime it gets smaller, you're multiplying by a number less than 1. Now, if we look at the length, y, 3 divided by 6. And that also reduces to 1/2. So in this case, we can see we made the height smaller by half, it's half the size, and also the length. Notice that these are both the same. Okay? In that case, we can say it's proportional. Let's get one more example. Now we have Luca here. He drew out a small right triangle. He's creating art class. So this is the original right here. And his mother liked it so much, she wanted him to create a second one. So he did, and this one's bigger. So we're going to do the same thing we did before. This is our X value, this is our Y. Original image, second image. And we're just going to plug in the information. So now we're going here from 0 up 1, 2, 3, 4, 5. So the height of the original is 5. The width, it looks like we're going from 5 to 1, 2, 3. Must be 8. So the width is 8. Nope, that is wrong. I hope you're like, no, it's not Mrs. Messing. We're going from 5 to 8, but we're going over 1, 2, 3. Width is 3. That's better. All right, our second image now. How high is it? We're going from 0 all the way up to 15. And its width, I'm going 5, 6, 7, 8, 9, 10. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Its width is 10. And all I'm counting is a distance from here to here. Or I'm saying I'm going from 5 to 15, that's 10. So if I want to find the constant, which we're going to need to do right here because it says, does a constant of proportionality exist? Well, let's find out. Y divided by X. So again, this is Y, this is X. 15 divided by 5 equals 3. Cool? So we know our height got 3 times bigger. But remember, to be a constant, it has to be the same for all of it. So if I go 10 divided by 3, well, there's no common factors. I could say that 3 goes into 10 3 times. Because 3 times 3 is 9, that means I have one of the 10 left over. So I have 3 and 3 1/3. So does that constant proportionality exist? Nope. Or just no. If not, explain. We go back to there is not a constant. Okay, something else maybe we should say is ratios aren't the same because these two things are ratios. Okay, these two ratios, 15 over 5 is not the same as 10 over 3. So back now to being enlarged. So if we're reducing it, we're multiplying by a number less than 1. If we're making it larger, we're multiplying by a number bigger than 1. So is his enlarged mosaic a scale drawing? Well, a scale drawing has to be proportional. You can't make one side 3 times bigger and the other one 3 1/3 times bigger. Just like if you had a map, you can't make its width half as small, but its length 3 times as small. Like you have to have the same thing for it to be proportional. There has to be a constant. So is it enlarged mosaic a scale drawing? Well, it's definitely bigger, but it is not a scale drawing. So we're going to say no. And the reason is there is no constant. I'm going to try to spell it right. Constant. I'm going to say of proportionality. Okay, there has to be one number that we're multiplying by. It's either going to make it bigger by proportionally or smaller proportionally. So down here in the summary, a scale drawing is an enlargement or magnification if it's larger than the original. If R, what we're going to refer to later as our scale factor, is greater than 1. A scale drawing is a reduction if it's smaller than the original. That is, if the scale factor, our constant, is a number between 0 and 1.